Hey guys, welcome to the beginning of this week of physics. We're going to be starting with Castle Unit 6, Activity 1 today. Now at this point, before you have begun this video, you should have already color-coded each of these circuits. That being said, I did go ahead and color-code them here, so if you were lost or if you weren't quite sure how to do them, I do have those color-coded already. Now, what I want to open with first is, up to now we've been color coding circuits to represent the electric pressure, but we don't have something yet to measure electric pressure. Now the tool that is used to measure electric pressure is called a voltmeter. This is obviously not a real voltmeter. This is a digital voltmeter that I have here. But what it does is it tells us the electric pressure difference, or the voltage, from one wire to the next wire. And what Activity 1 is having us do is it's having us measure the voltage or the electric pressure difference between different places in our circuits. Okay, so you see here on this digital circuit that I have here, we have a circuit with a battery and two light bulbs. And here is, again, it is just this circuit here. And what we're going to do with 1A is we're going to take this voltmeter and we're going to attach the wires of the voltmeter on either side of the battery. And you see I have a 9-volt battery right here, and the voltage reads as 9 volts. Now what about B, where I'm measuring from the top of this wire here, okay, the top of this light bulb, to the bottom of that light bulb? Well, I see 4.5 volts. Notice that that is half of the 9 volts. Oh, and you'll see also for this one here, for this bulb, when I measure the voltage across this bulb, I also see that same 4.5 volts. Again, half of that 9-volt battery. So we have half of the voltage is around this bulb here, and half is around the second bulb there. And if I measure if I do D here, and I measure from the bottom of this bulb to the top of this bulb, then I get 9 volts. So we saw A was 9 volts, B and C were both 4.5 volts, being half, and D was 9 volts again. And so you see that from blue to red, that was 9 volts. From blue to red, that was 9 volts. But from red to yellow and from yellow to blue, they were both half of that 9 volts. I'm going to move on to number 2 here. Okay, doing something similar. We're just going to measure the voltage first across the battery. We see, again, 9 volts. And then around the first branch, again 9 volts. And around the third branch, C, again we see 9 volts on our voltmeter. And so we confirmed that in parallel, this red to blue pressure difference, that 9-volt pressure difference, exists for all of those bulbs in parallel. Go ahead on to number 3. Okay, now we have 2 long bulbs, and you might be wondering, well, Mr. Deedley, there doesn't seem to be a difference between the long bulbs and the round bulbs. Notice that I have made the resistance of the long bulbs about 5 times as much as the resistance of the round bulbs, which is what we have in our classroom. Actually, they're about 5 times the resistance. Okay, we should see what we have seen so far with our color coding, right, is that these are color coded the same, right? 1 and 3 are color coded the same. So we should see the same thing, right? From blue to red on the battery, again 9 volts. And then again on the first light bulb, again 4.5 volts. And then finally, again around the last bulb, again 4.5 volts. And across both bulbs, again, 9 volts. Okay, number 4. Again, pretty much the same as number 2. You see the color coding is the same. The only thing difference is the resistance of the bulbs. And you should see then that since the only thing different is the resistance of the bulbs, we should see exactly the same thing as we did in number 2. And it does appear that again we see 9 volts across all of those bulbs for A, B, and C. Okay, number 5 is a little bit different. We have 4 round bulbs in series. Let's take my voltmeter and see what happens. Across the battery, first A. Again, we see that the battery has that red to blue. And so again, we see 9 volts across the battery. On the first bulb, we see 2.25 volts. And on the second bulb, also 2.25 volts. And for D, also 2.25 volts. And for E, also 2.25 volts. And what you might notice is that if you multiply 2.25 by 4, right, if you add all these together, the 2.25 here, the 2.25 here, the 2.25 here, and here, you would get 9, right? And so that's why if I were to measure from the bottom of this light bulb all the way to the top of this light bulb, we do still see that whole 9 volts from here to here, F. Okay, numbers 6 and 7 we see are very similar to each other, and you'll see that I've color-coded them to show that the round bulb has a very small pressure difference across it, right? If the round bulb is on the bottom here, then that would be from blue to somewhere between blue and green. Whereas if the round bulb is on the top, like it is in number 7, that would be somewhere between red and orange. Okay, so this is how I've color-coded them. And so basically what we're saying is that we should see a larger pressure difference across the long bulb, the one with the higher resistance. We also see that that is the one that is brighter. Okay, so let's look at those. This will be number 6A. We see again, like usual, is 9 volts. Number 6B, we see 7.5 volts. That is most of 9. It's not all of 9, but it is most of 9. And if we look at this bottom one, go ahead and think about it, right? What we've seen so far is that it has to total up to 9 volts. So if this one had 7.5 volts, this one should have 1.5, right? Yeah. Okay, so this round bulb down here, the one with lower resistance, has about 1.5 volts across it, as opposed to the 7.5 that's on the long bulb. And if we do measure from the bottom of the round bulb all the way to the top of the long bulb, we do see that that is still 9 volts across the whole bulbs in series here. Okay, this is pretty much the same as the last one, except for with the long bulb on the bottom and the round bulb on the top. That means we should see the same thing, or the same amount of pressure difference across each bulb. Okay, we have 9 volts here. Again, across the round bulb, we still see 1.5. Even though we've switched the round bulb up to the top, we still see a 1.5 volt pressure difference. And across both bulbs in total, D, we still have a total of 9 volts. Because this long bulb has 7.5 volts, it takes 7.5 volts of that pressure, and that round bulb still only takes 1.5 volts of that pressure. Okay. On to numbers 8 and 9 then. Number 8 we see is just one long strip of bulbs in parallel. And we should see that since they're all in parallel and they all have that red to blue pressure difference, we should see that all of these bulbs have 9 volts across them. Now you might remember from the last few days that if you put more bulbs in parallel with each other, what we see is that their brightness actually starts to get lower because the battery does have an internal resistance. And you see that right here I do have a little box that lets me turn up the resistance of the battery. And if I do that, then the pressure difference across this bulb gets to less than 9. And if I take this bulb off, right, the more bulbs that I have in parallel, the lower the resistance is, the less the pressure difference is across the battery, if I do have some resistance in my battery. And so the more resistance is in my battery, the less pressure difference is going to be across it as I make the circuit bigger. Okay, but in principle, if we have a fresh battery that has no internal resistance, they should all be 9 volts. Okay, and lastly, number 9, right here, this nice big circuit, we have a couple of things going on. We've got 3 different sets of bulbs in parallel. One that's just 1 bulb, one that's 2, and finally one that is 3 bulbs in series with each other on that last branch. Okay, we can see the voltage across each branch. Okay, if I go around the battery, I see 9 volts total around the battery. That means I should see 9 volts total around the first bulb again. And I do. And then I can also take a look at the voltage or the pressure difference across these 2 bulbs. And you see that these 2 bulbs both split that voltage in half, from 9 to 4.5 across each one. And since I have a total of 9 volts, that means that each of these 3 bulbs should take 1/3 of that voltage, which would be 3. And you see I do have 3 volts across the first bulb, 3 volts across the second bulb, and 3 volts across the third bulb. And if I were to measure across every single one of these, all 3 of these, again, I still see 9 volts. Okay, so that's the basic principle of what we have going on here. We'll start to get a little bit more into the math and the numbers. What you'll do tomorrow is a worksheet that is going to kind of assess how well you learned from this activity. Real quick, we're just going to go through the consensus here in this same video to make sure that we do have enough time to do that. Okay, so here's the notes right here for activity number 1. Okay, first thing, the voltmeter must be connected in parallel with the other things in the circuit. You'd probably notice that I didn't ever take anything out and try to measure it like this. Now I can put the voltmeter there and it does give me a reading, but it's doing something different when I do that. And we'll get more onto exactly why that is a little bit later. Okay, second thing is when connected in parallel, the voltmeter readings are consistent with electric pressure difference values based on the color coding. What that means is that red to blue, assuming that all my batteries are 9 volts, the red to blue is 9 volts. Okay, and the red to yellow was half of that, 4.5 volts, etc. Okay, in series, the individual pressure differences across each resistor add up to the same value as the electric pressure difference across the battery. So in series, the individual pressure differences, that is, for each bulb, I will see that it does add up to the total value. And finally, in parallel, the electric pressure difference across each branch is approximately the same as the electric pressure difference as the battery. My 15 minutes are up. Bye.